Hey everyone, StatsGuru here, and in today's video I want to touch on hypothesis testing. And I kind of want to explain this the best way that I can, just highlighting some of the basics that go into hypothesis testing, and then from hypothesis testing look at some of the tests that are going to be potentially used with it. So to get started, some of these icons on the left here are what you may see or notice or be familiar with. The first of which, HO, is what we call the null hypothesis. So this is the null hypothesis. The null hypothesis is our starting point, so you can think of this as the first thing that we're looking at doing. And with that, it's kind of our ground zero, if you will. So we're going to be testing against our null hypothesis. The other one, which can be noted as HA, is our alternative. So this is our alternative hypothesis. So with the alternative hypothesis, this is where the excitement is. This is what we're trying to find evidence to hopefully support. And it's really the opposite of the null, so it's what we're trying to disprove. So it's the alternative to the null. Another symbol here we have is alpha, so this is our alpha value. And the alpha value is really the level of confidence, so it's used when we're doing our statistical testing. A very common alpha value is 0.05, or what we call 95% confidence. So we'll get into this in a little more detail as we dive into some of the specific tests. But just know that that denotes our alpha value, and typically it's 0.05. Then we have our confidence level. Confidence levels are what are the true mean falls between. We have a few different ones. You have, again, your 95% confidence interval. You might see a 90% confidence interval. You might even see a 99% confidence interval. So those are some of the common ones that appear while working with hypothesis testing. So if I were to visualize this for you, so if we were to look at our confidence levels here, so let's go ahead and draw our graph and draw our bell curve. We have our center point, okay, which we know to be our mean value. So when working with this, if we have an alpha value of 0.05 or a 95% confidence interval, what that is telling us is that we are going to be 95% confident that the mean is going to be between these two values. Okay, so we're 95% confident it falls within here. Well, what does that leave us with? Well, that leaves us with two endpoints. So we have two tail ends, if you will. So each of these tail ends contains what? Well, these each contain 2.5%. So we have that on both sides. And that is what we're accounting for as our error. So we're going to have 5% error while we have 95% confidence that we're within this specific range. Now if we want to have a 90% confidence interval, and if I do that in a different color, what that means is we're now increasing our error. So what we're doing is we're now shortening the values that it falls between, right? So now we're going to be 90% confident that we fall within this range. So we're going to be within this range. And now our error is a lot bigger. So now we have 5% error on each side of the curve, right? So now this is getting a lot bigger. So even though that we are shrinking, if you will, this area that we're looking between, we're actually now at a 5% error chance on both sides. And then if we have the other direction, so if we're looking at a 99% confidence interval, what that means is our end values are actually way out here, and we are 99% confident that our value falls within the range, which means that we expand the edges of our range values, right? So we're 99% sure that it's going to be within this range. But at the end of the day, that only gives us a 0.5 0.5% error on both sides, right? So we're having a 0.5% because that would be 100 if you add those together with the 99. So as a standard in the middle, we like to go with a 95, simply for the fact that a lot of our statistical tables, whether it's in the back of a textbook or things that you work with on the day in and day out in statistics, is just a very, very universal standard. So we're gonna, for the purposes of the statistical tests that we run through, are going to be using the 95% level, or the 0.05 alpha level. So with all that being said, these are what we typically have as our statistical tests when working with hypothesis testing. So all of these are examples of using a hypothesis test strategy. So we're going to have a null and alternative hypothesis when diving into each of these, and using that alpha value as well as potentially some of the tables, whether in the back of the book or you can find them online. So these are just some examples of tests that use hypothesis testing. Again, I just wanted to touch on the null and alternative hypotheses, as those are kind of your starting points. We then use these statistical tests when doing hypothesis testing based upon the data that we're working with. From that, we then have our conclusions. So let's go ahead and look at some conclusions real quick. So these are the typical conclusions that we work with. Number one, do not reject HO or the null hypothesis. So we do not reject that. The other one is that we do reject the HO or the null hypothesis. So for the first one, when we do not reject our HO or null hypothesis, what does that tell us? Well, when we do not reject the HO or the null, what this tells us is that there is not enough evidence. There's not enough evidence to reject HO or H null. So that means that there's not enough evidence to reject H null, but we do not accept it, right? So we're not actually saying we're accepting the HO or the null. What's happening here is we're not rejecting against it. So there's nothing or not enough evidence in our test that we're doing to prove it wrong. That's simply what we're saying here. So that's the first instance of some of the conclusions we work with. The second one is the exact opposite. So now we're rejecting the null hypothesis. So when we reject the null hypothesis, we say that there is enough evidence. So there is enough evidence to reject the null hypothesis and conclude that blah, 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 whatever that might be, that blood pressure was actually higher after patients took a specific drug. Or we can say we reject the null hypothesis and we conclude that the Huskies run faster than labs based upon their run time, or something like that. So that's really the two differences. We have do not reject, which isn't accepting, simply not enough evidence to reject the HO. Then we have the second option, which is, of course, we reject. Our statistical test found that there actually is a significant difference, and we'll get into that as we look at those tests. But there is a significant difference, therefore there's enough evidence to reject the null hypothesis, and we can conclude that blood pressure was lower after taking a drug, something like that. So again, just kind of wanted to run through some of these hypothesis testing basics with you guys, just to give you an idea as we move into actually doing some of the tests and walking through some examples, that you have a better understanding of what we're looking at and working with. As always, guys, I love making videos and statistical topics. Make sure to hit that like button, subscribe, comment down below any questions you might have or any topics you want a video made of. I'll be happy to do that for you, and we'll see you in the next video.